So we're studying, we're evaluating, we're modeling spatial data. And what is that? So spatial data are data that are located somewhere on the surface of the Earth. It could be on the ocean, but has an XY location, has a coordinate. It is located somewhere specifically. And that spatial information is what makes a data set spatial. So this chart that I found shows you an idea of after-school programs and the school addresses. One of the things that we can do with when we're doing spatial analysis is we actually incorporate both non-spatial and spatial data in our data sets to better understand everything. So one example is if we have a polygon of University of North Florida, and in there we have different polygons representing the buildings. Those buildings have locations, so that's spatial data. But within that spatial data set, that can be what we call attribute data or non-spatial information, such as the number of floors, the number of elevators, the number of bathrooms, the number of classrooms, the number of desks, the color of the building, the year it was built, right? The construction, is it brick or something else? So keep in mind, while we usually are talking about spatial data, we incorporate both. But for this to really work, we have to have locational information in our data sets to move forward. All right, this also includes spatial analysis, examining patterns, locations, attributes, relationships, changes. And one of the words or buzzwords or monikers, however you want to call it for this, is also called location analytics, especially in the business and business GIS, where we're looking for insights, right? That's the whole point. You're trying to use a bunch of different data layers that have locational information. Each one can be different. And you put them all together, you query them, you analyze them, you look at this relationship, you ask questions. And when you do that properly, you can get some interesting answers and help solve problems and even shape policy. Some questions to consider is what is going on, where, when, and why. So the where is a key component to everything we're doing because everything is located somewhere, and that somewhere matters. So for us researchers, especially if you're in the social sciences, is how do you convert your data into spatial format? How do you interpret it and then display them? When we're talking about displays, we're almost always talking about a map. So for us in spatial analysts, we almost always end up with a map. And the map is the result of all our analysis, all our thoughts, all the work we put into, and then we provide a visual output of communication. So as opposed to displaying a data table, we actually show a map. And a map is something that people can relate to. They can look, they can see patterns, colors, possible relationships. A map also results in more questions. Well, what's that there? What's going on? Why is that highlighted? Why is this area blank? Whatever it may be. So this is key. Is once you start mapping your data, before you even do any analysis, that in itself will set things up for you to ask better questions. Why do we use this methodology? As mentioned earlier, location matters. And as the saying is, everything happens somewhere. Many of you that maybe aren't using spatial data or spatial analysis or spatial thought in your research, you probably do have this embedded, that location is there, but maybe it's not a part of the data set per se. But if you're analyzing oyster beds, or if you're looking at voting patterns, or looking at student performance across different locations or schools or countries, disease rates, crime, all of these things happen somewhere. And that specific location matters because of the characteristics that are endemic to that particular location. We don't believe, as spatial analysts, we don't believe that humans act the same way everywhere, that we follow general laws, as some general economic models tend to assume, right? That humans behave in a certain way, and we can predict that. We, as spatial analysts, assume that that's not quite the case, that people behave differently in different locations. For example, coastal Portugal, in Nazaré, the people there have different histories, backgrounds, tastes, preferences, cultures, language than across the Atlantic, right here in the US and the coast of Virginia, for example. All that matters. We can't assume that everybody is the same. So we'll talk more about that a little later. The world we live in is not uniform. As you know, resources, biomes, people are not distributed evenly. So this uneven distribution in itself shows you the importance of spatial analysis and why location matters. Here's a quick example. Here's a map showing oil and gas wells from the USGS, U.S. Geological Survey. And again, as you can see here, well, not again, but as you can see here, this is not evenly distributed, right? Not all the states in the U.S. have equal share of oil and gas energy supplies. They are located in specific areas due to geologic history mainly. And that indeed matters. It affects the economies, the jobs, the tax base, the environment, pollution, and energy supplies, everything that you can think of. And that is, again, location dependent. Here's another map, again, showing the uneven distribution, in this case of biomes. Think of this as the places where people live, and that shows how our planet is organized in terms of mainly temperature and rainfall. Those are the two main components of climate. When you look at temperature and rainfall, and you're able to map that, that will tell you a lot about a particular area. And that will also tell you where things can grow, plants, animals, and where people can live comfortably or not. What kind of questions? Again, what is there and why? Why is this there? Right? That's another important location. Okay, I've mapped it. So why is it there? What's going on? How are things related? Those are other important questions to ask. And what helps explain this? So one of the challenges, as I mentioned at the beginning, right, is that we need other researchers to help us. If we're studying imagery, for example, say satellite image, and I'm looking at changes over time, I can tell you, or the imagery can tell me what is going on and where, but it can't tell me why. We need to know more. That's what we need researchers, maybe biologists, social scientists, sociologists, anthropologists, geographers, others who are out in the field and are conducting interviews, gathering field data, and understanding why certain things are happening. So we have to put all that together into this big spatial analysis package, if you will. What sorts of answers can be attained? Well, we want to uncover spatial variations or similarities. We want to understand human environmental interactions. This is the school of thought called possibilism. If that is, it's a French school of geography, which says that the environment provides certain limits, if you will, to what humans can do. But from there, then humans are very creative and have a long history and cultural practices to develop and move forward as they will. So this is different from environmental determinism, where the environment determines how humans develop and how cultures are. That was an idea that was an older idea that has been obviously dismissed. But here we want to say that the environment does provide some limits, right? Antarctica certainly provides some limits as to what we can do and live and grow. So is the desert. But within those limits, if you will, we are very creative when we're able to produce life, culture, societies, and they do differ. So not all mountain cultures are the same, for example. Not all desert cultures are the same. All right. What are some of these social, political, environmental, economic factors that help explain all of this? Again, back to this big picture of having a team of researchers. And for us, geospatial analysts or spatial analysts, is how does this vary across space? We're looking for variations. We're looking for patterns. We're looking for distributions, trying to understand what is going on and where and why that is important. Okay, so why do I use this? Sorry. Part of the reason I'm maybe hesitating is that the Zoom screen is blocking, there we go, part of the slide. There we go, I just moved it. All right, so how do you use the methodology in your research? Well, I do use it all the time. That's my reason for being, if you will. And some of the projects I'm studying already, Dr. Clayton mentioned at the beginning of the talk. All right, there we go. So here's an example. This is the Grand Ethiopia Renaissance Dam that is being built on the Blue Nile in Ethiopia. It's rather contentious because they're damming part of the river that ends up in Egypt. And a lot of the water there's concern that a lot of the water that's being tapped here will not be able to supply a lot of the farms and agricultures in Egypt and even in Sudan. But why we do spatial analysis, why it matters, why it's fun, why it's cool and useful is, look, at the top you see an image of before things went in, before the dam was built. And then in the bottom too, you can see how in the imagery we're able to show two images. I don't know if you can tell, I don't know if you can see my mouse, but there is a line right about here, if you can see that. These are two satellite images, two Landsat satellite images with 30-meter spatial resolution. What that means is 1 pixel equals 30 meters on the ground, or about 90 feet, right? So this is considered coarse spatial resolution. You're not going to be reading license plates. But the Landsat system has been around since 1972. It's a global Earth observation system of imagery for everywhere in the world, and images are gathered every 16 days. So this is a great source for you to find images of your study area and see track changes over time. So with using some of the tools that we use in geospatial analysis, is we took two of these images and we mosaiced them together. Then we created what's called an NDVI, Normalized Difference Vegetation Index. Simply is that we're using information in these data sets, right? So the imagery are data. So we're using information in these data sets to create an index which shows where healthy vegetation is located and where it's not. And as you can see, the green would indicate vegetation and the yellowish would indicate not. So because of the NDVI is able to distinguish water quite well, we can use this, for example, to tease out the water in this image. And what this water represents is the amount of land and water that has now spread out over this area since the building of the dam. You see up here, there wasn't, this was a natural area, and now all this has been flooded. So some of the concerns, if you're studying this, is, okay, how much the land has been flooded? What's been flooded? Settlements, historical monuments, others, natural areas of habitats. And so through these methods, we're able to not only look and see this, but even categorize and, we're able to calculate the amount of land that's been taken up. So as you can see here, about 850 square kilometers of land has been flooded based on 2022 imagery using some of the spatial analysis methods. All right, so how do you use this in your own research? Yes. I'm just continuing that question. Some of the tools that we use, if you're out in the field, you have your field notebooks, you're taking notes, you're observing. You work with paper maps, either that you have with you or that you draw, or both. A GPS receiver is very important because we want our location again. GIS phone apps. So with your phone nowadays, you can gather, collect a lot of spatial data. It's made quite easy, not only through GPS apps in your phone, but also apps that are made to gather GIS data like points, lines, and polygons, and add information about that, which we call attributes. They can be uploaded to the cloud. So when you get back to the office, the information is there and mapped, and you can then start analyzing it. It's quite amazing what we're doing today. In imagery, lots of imagery is out there. Not only satellite imagery, but air photos. And even better now, with the advent of drones and aerial photography equipment, we can acquire our own imagery of our study area. Why do we want to do that? A, because we have high resolution results. Remember I mentioned earlier that Landsat has 30-meter spatial resolution. And while you can find higher res imagery than that, like NAIP, National Agricultural Imagery Program, which can be sub-meter, 6 sub-meter accuracy, sub-meter resolution, gathering your own allows you to have updated imagery of your study area. So it can be as early as yesterday or last week or last month when you went out in the field. And it's very hard to get updated imagery without having to buy it. And number two is it is high resolution. You can see a lot of detail in there, and you can examine what's going on and do some pretty good analysis. So that's the reason why we're really into drones and aerial photography. And as a researcher, this is something that you can also incorporate. Back to aerial photography, some of you may or may not be able to fly a drone. You may not have a license. You may not have the equipment, the money, the permits, whatever it may be. So there are alternatives which also provide pretty good results, and that is aerial photography using kites and balloons, where we attach a camera up to this platform, fly it up in the air, and try to move around like we do with a drone and gather images along the way, and we stitch them together as we do with drone imagery. And pole photography does the same, it's just much lower elevation. And so I've kind of answered this already, but it allows me to do everything that I'm doing in my research, because it helps me know what's going on where. And more interestingly, perhaps, is what changes are taking place, right? So it's not just a static map or static finding, but showing changes over time and trying to understand those changes and perhaps even help model and predict future changes. We want to ground everything in a particular location. We're looking for patterns, we're looking for relationships. So from now on, every time you're out in the field of gathering data, even if it's on the internet, try to acquire the location, try to note it down, either as an XY or as an address. For us, it's not just about spreadsheets and mathematical models. It's more about maps and imagery. Yes, obviously I do this because the classes I teach are all geospatial analysis related. We talk about GIS, remote sensing, and GPS. Those are the three pillars or three corners and triangles of geospatial technologies, right? So GIS is Geographic Information Systems, system of computers and software to create maps, to analyze, store, retrieve spatial data. Remote sensing refers to imagery. Technically, it refers to gathering information about a location while not necessarily being present. So that goes back to the Earth observation satellites, air photos that were flown from a plane. But today now, as I mentioned earlier, it refers also to drone imagery and aerial surveillance that we're doing. And then GPS, right, the global positioning system that allows us to locate everything on the Earth quite accurately. So students learn to think spatially. That's one of the things that we're trying to do is, wow, location does matter. How does this play in? What does this particular place have in common? How is this located here? What is the relationship? How far is it? What's nearby? What's being affected? All of these questions that perhaps start to become more clear or even get asked once you're more aware of the importance and the value of location. And then, of course, is the visual communication of results from all the analysis in the form of a map that therefore clearly shows what we're trying to convey if the map is done well, right? So there are actually two components to this. The first part is the spatial analysis. We're able to acquire the data, produce it, download it, get it, however it is, put it together, ask questions, analyze it, process it, get to the point where you're answering some questions, you're providing some results that are useful. That's step one. Step two then falls more into what we call cartography, where you're actually making the map and making it look pretty, right? Adding the title, the scale bar, the north arrow, changing the color, moving this around, changing the base map, the part that makes the final map look good and also communicate what you're trying to communicate. So there are two aspects there. Often we spend more time on the analysis than we do on the map making. So here's a model. I talked about models that not necessarily economic models, but the reason I show you this is this shows you spatial thinking. It shows you spatial analysis by taking different data and applying particular steps and process it to create an output. And you take that output and then you ask another question of this. Show me this. Show me, for example, this is a model we used in an exercise for class where they had to try to tease out male panthers that were being killed in South Florida along particular roads. And so we had to get a data layer of the Florida counties, and then we had to select information about it. We had to export it. That resulted in 3 counties. I don't know if you can see my mouse or not. It's moving on the 3 counties. Then from there, we're able to add a field, add information, calculate the size, right? We're able to clip. We're able to take that data layer and ask more questions and compute, export those features. So what you're seeing here is just a bunch of different steps that we often do in isolation. Ask a question, it produces this. Then you take that data set and you ask this and it produces that. And so we end up often with 10, 20 different files. Well, if you're able to organize your thoughts, organize the analysis that you want to do, this is one way to do it in a model. And what the beauty of this is it can be saved, it can be reused, you can change some of the data and parameters and run it again. You can share this model with others who have the same data sets. And so it's a great way to organize your spatial thinking. Think of it as object-oriented programming, and it's quite useful. All right, moving on. What opportunities does this create for students? Well, a way to work with and understand field location and data. A lot of students we get come from biology, also have archaeology students, but transportation and logistics, engineering, for example. So being able to work with spatial data, knowing the value of location is very useful. And for many students, they're being asked to take GIS, either as an undergrad or in grad school, and in many of these fields. Not only that, but jobs and internships are asking more and more for GIS. So even students who are trying to get a job, not necessarily as a geospatial analyst, but maybe in analytics, let's say, and they have the spatial analysis skills or understanding or basic concepts, they become more valuable than a student who doesn't. So this is the reason why spatial analysis matters, because it provides another way of looking at the world, helping understand what's going on where, and provide information that is useful, actionable data and insights. And so here are some examples, and probably if your discipline is not on here, I'm sure we could fit it in, because location data more than likely does apply. Okay, how can we get started if you're a faculty? Well, read up about spatial analysis, geographic thought, for example, location. There are many books. Some are more interesting than others. Some are more Yifu Tuan, like place and space, for example, if you're more interested in kind of the cultural and the thoughts behind there, the psychology, if you will. Ask yourself, what are locational components of my research? This is an easy one, right? Where is my study area? What is taking place? What am I studying? Where is this taking place, and why does that matter? So if you're doing that and asking those basic questions, then you can look at XY locations. Can I add? Can I find it? Can I record it? Can I find that soccer stadium that I visited? I'm making this up, right? Soccer stadium that I visited and where I interviewed these 10 people about a particular question, let's say in Colombia. Yeah, I can go to Google Maps, I can find that XY location, I can map it, I can add that to my data set. Can I take geotag photos? Yes, most of us already have location analysis or location permission set up on our phone. So when we take photos, the photos are geotagged. We can take those geotagged photos and convert it to points on a map, and even do a little hyperlink to a thumbnail of the image. So there's so much we can do now quite easily that maybe you haven't thought about. You can digitize features. You can create your own points, lines, and polygons. And you can do this also in Google Earth. And Google Earth is free, right? We call it a geo browser, and everybody has access to it. You have to install it. There's even a web version, but it's free, whereas the GIS software is not free. But we do have a university-wide site license, and if Robert Richardson is on this call, I hope he'll talk a little bit. He can tell you more about that. In terms of finding out more, is watch YouTube videos. There are Coursera courses. There are the Udemy and others that have even free courses from top universities where you can learn more about spatial analysis. And Esri has a lot of training. The reason I mentioned Esri is the maker of the GIS software that we use on campus, ArcGIS Pro. And we have a university-wide site license, which allows all the researchers, all the faculty here to have the software installed on your computer if they want. Just ask ITS and they will do it. And once you're part of Esri, you can sign up for an account. Well, you create an account. You can sign in and you can access a lot of training information that's quite useful, and tutorials and what may be. There's also GIS Online, ArcGIS Online, where you don't even need to install the software, you just need a browser, and that is really developing. So you can start doing basic mapping and analysis right off the bat without even having to install the software per se. You just need an account, and Robert can help you with that.
Dr. Baynard mentioned the ESRI site license. This is a great tool that's available to any faculty, student, or staff. Anybody can. It's made up of basically two parts. It's got the software part, which is the desktop part. Unfortunately, it's only available for Windows users, but then there's also the organization, which has all kinds of other resources that you can use. It's a great tool with stuff like the ArcGIS Pro. It has field maps where you can go out and collect data with either your phone, or if you have a very high accurate GPS, you can basically create a data collection survey that you can go out and collect data from your phone. Story maps to create a story of your project, where you can show your map, show your data up there for people to view. Survey 1, 2, 3, which is kind of like Qualtrics, but it's more designed for GIS. You can go out and collect data and have it live fed to a website that can show you as you're entering the data that can come up. So there's a lot of tools available in the site license that any faculty or student can have access to. As long as you have an N number, you can access it. So it's a great tool that if anybody has any questions, they can always contact me and I can help them get started with that.
Just some quick examples. So here we had students who walked with a GoPro camera through the trails at UNF, and the GoPro had video on. So that video, it's a GPS video, is recording the locations as they're moving through space. And then we can go and convert those points as a GPX file to points on a map, which one you can even convert to lines. And so you can see the path that they followed that would not be even seen normally. So this is one way to acquire data, is use your GoPro camera and put it on video and then extract the telemetry data from there. This is an exercise we're working on this semester with students in the honors program. They're trying to create an online map that immigrants moving to Jacksonville and live here now can access to find services that appeal to them, specifically medical, health, legal, educational, and others that are particularly important or interesting to the immigrant community. And so the students started off by creating locations on a map using Google Earth. You would type in, for example, food pantries in Jacksonville, and then they would go to each one and they would look at it and they were able to copy the address, the name, the address, basic information such as is there a website or a phone number into a data sheet. So it's as easy starting off with a data sheet. And then you can type, once you've typed that in, we can convert that to points on a map. In this case, however, what you see here is a combination of things. They created points in Google Earth. So if you typed in a location, or even just zoomed in and typed in food pantries and saw that there was one listed, say Lutheran Services on Cassett Avenue, I'm making that one up. Then they would go in with a place mark tool and it would put a little push pin there, and that would create a point location, and that could be saved. So all these point locations are color coded. And not only is that information now being built in Google Earth, but it can be exported and then brought into ArcGIS, so the GIS software that we use, and you can do more advanced mapping and analysis. So this is what you see here, a combination of them having created information in Google Earth and brought it into ArcGIS. This is a map we made for one of our presentations. We were looking at as Dr. Clayton mentioned earlier, Dr. McCraw mentioned earlier, the gold mining. So illegal and artisanal gold mining in southeastern Venezuela is clearing, and not only clearing, but really degrading the tropical forests in this part of the country, in this part of Northern South America. And so through some of the tools of spatial analysis, we're able to calculate the amount of land that is being cleared. So we have not only calculations, but you also see where it's located. And in terms of being able to provide information that's interesting, or perhaps that the audience can understand a little bit better, we take it from square kilometers to football fields. So FIFA regulation soccer pitches or soccer fields. And in this case, you can see by 2020, I didn't show you the scheme of it, where it all began. That's for another presentation. But by 2020, you can see that 3,100 soccer fields of land had been cleared. And so people can visualize a soccer field. So if you think of 3,000 soccer fields, that's a sizable number. So again, this is another way to communicate your results that are based on location. And this is using Esri Wayback. If you type in Esri and Wayback into a browser, you'll likely be taken here. And this shows you high resolution imagery that dates back to about 2014 from, I think, Maxar, satellite imagery company. And it allows you to look at changes over time. We created this GIF, and you can see how that's just the same gold mining area that we just saw a minute ago, how it goes from 2014 all the way through 2023. And you can really quickly visualize the changes in the land degradation that's occurring. So those are other tools you can use to at least look at your data sets and start asking some better questions, perhaps. The map, I think we grew up thinking that maps represent reality, and maps are more of interpretation of reality, or interpretation of what we want to show or how we see the world. For example, if you can, I don't know if you can see my screen behind me, right? That is an image there down near Setúbal in southern Portugal, acquired this summer using kite aerial photography. So I have a GoPro 11 mounted on a kite, walking across this property and creating individual images that are then stitched together like drone imagery is to create this orthomosaic, right? An orthomosaic is where all your images from air photos are stitched together in a way that reduces or removes the curvatures and distortions and renders distances accurate. Well, that gives you particular appeal, if you will, or information about what's going on there. But perhaps by not including maybe what's going on here, which is maybe the huge plantation house, I'm making that part up, but there's a house, or not even showing something here, you get a certain perspective. Or even back to this model, the fact that it was acquired during the summer shows you green, vigorous vegetation. Perhaps if I acquired this in the middle of the winter, you would see senescence and plants either dying or being harvested, what may be, and gives you a different perspective of what's going on. Another thing, again, just jumping on this example, is the tides here. The tides, if I recall, are something along the lines of 15 feet or something, which is quite astonishing for us. We're used to 6-foot tides here in Jacksonville. So things really go way out. That affects what's going on there. But in terms of mapping, I could get this information. I could relate it in a way that provides perhaps more accurate information. I could also relate things that maybe exclude. And so that kind of is a discourse in itself, just from an image, if you will.
Great.